Greetings of the day. Welcome to R.M.K. CET. I am Pratima, currently dealing the course Signals and Systems. In this video lecture, I am going to explain properties of discrete time Fourier transform. This topic will come under 4th unit. Now, the first property, linearity property. If Fourier transform, discrete time Fourier transform of x of n is x of e power j omega or x of omega, then Fourier transform of linear combination of two signals, that is a x1 of n plus b x2 of n, is nothing but a into x1 of e power j omega plus b into x2 of e power j omega, where a and b are constants. So we know that the Fourier transformation formula is discrete time Fourier transformation formula is summation n is equal to minus infinity to infinity signal into e power minus j omega n. So summation, the operation summation itself, it satisfies linearity property. So we can split the operation and we can take constant outside of the summation, so that we will get a into x1 of e power j omega plus b into x2 of e power j omega. So this is the first property and simple property of Dtft, that is linearity property. Next property, time shifting property. If f of x of n is equal to x of e power j omega, then shifted version of input signal x of n minus n naught Fourier transform is e power minus j omega naught x of e power j omega. So if it is shifted by n naught units, delayed by n naught units, then its transformation is multiplied by e power minus j omega n naught. So here the first equation representing Fourier transform, discrete time Fourier transform equation, and we are going to find Fourier transform for x of n minus n naught. So instead of x of n, we will substitute x of n minus n naught, since we are going to find out Dtft for x of n minus n naught. Let a new variable lambda as n minus n naught, so that n will become lambda plus n naught, and substitute here n minus n naught place lambda, and in the place of n, lambda plus n naught. So we can split e power as e power minus j omega lambda into e power minus j omega n naught. So we can write e power minus j omega n naught outside of the summation, since it is a common term. So now the Fourier transform for x of n minus n naught is equal to e power minus j omega n naught x of e power j omega. So this is time shifting property. If it is delayed by n naught units, its transformation is multiplied by e power exponential power minus j omega n naught. Next property, time reversal property. This property says if the Fourier transform x of j omega is for x of n, then its reversal, time reversal version, x of minus n will become x of e power minus j omega. Instead of plus j omega, omega will take negative values for negative time. So similarly, the first equation is representing discrete time Fourier transform equation. So we are going to find out Dtft for x of minus n, so that we have substituted x of minus n in place of x of n, and assume minus n as a new variable m, so that the limits won't change. We are adding from minus infinity to infinity or from infinity to minus infinity, the same we will have. So m is equal to, now m will become, here also m will become minus infinity to infinity x of m e power minus of minus omega m. Minus minus will become plus, so no, there is no change, and it is looks like e power minus j omega m. In place of omega we are having minus omega, so we can write it as x of e power minus j omega. So what time reversal property says, if the time is having negative values, then its transformation will also have negative frequencies. We go for next property, that is time scaling property. If x of j omega is dtft for x of n, then for scaled version f of x of an is will become x of e power j omega by a. If it is multiplied by a, it is divided by a in frequency domain. So similarly, this is the formula for dtft. So we are going to find now for dtft for x of an. So put x of an here and assume an as lambda. So n will become lambda by a. So substitute here and write it is in the form of omega by a. Lambda by a, you write omega by a. So how it looks like, x of lambda e power minus j omega lambda. In place of omega, we are having omega by a. So now the frequency will become x of omega by a. So if it is multiplied by a units in frequency domain, it is divided by a units. This is about time scaling property. So we will see next property, frequency shifting property. So similarly, like time shifting, for frequency shifting, what will happen? So here consider the signal e power LHS of the equation, e power j omega naught n x of n summation over n is equal to minus infinity to infinity e power j omega n x of n e power minus j omega n naught. So how we can write? We can write x of n e power minus j into omega minus omega naught. We can write like this into n. So in place of omega, what is there? Omega minus omega naught. So it is dtft of omega minus omega naught. So in frequency it is shifted by omega naught units. In time domain it is multiplied by e power j omega naught n. So this is about frequency shifting property. Next property, differentiation in frequency domain. So differentiation in frequency domain, dx of omega by d omega is nothing but Fourier transform, discrete time Fourier transform for signal multiplied by time. Let us consider dtft equation first, then differentiate with respect to omega on both sides. So with respect to omega, we are differentiating means x of n will become constant, e power minus j omega n, differentiation is minus j n is constant, e power minus j omega n, e power minus j omega n. That is equal to, we can write minus j outside of the summation. So we can write n into x of n e power minus j omega n. So we can take j to this side and n into x of n. So it is in the form of dtft of this signal, which is here n into x of n. So differentiation will frequency domain will leads to multiplication in time domain. Next, convolution in time domain. This is an important property while dealing the systems, while analyzing the systems in 5th unit. We use this property. Convolution in time domain will leads to multiplication in frequency domain. So if x1 of omega is dtft of x1 of n, x2 of omega is dtft of x2 of n, then convolution of x1 and x2 dtft will become multiplication of individual dtfts. So this is the convolution sum formula. So since it is a discrete time signal, we are using convolution sum instead of convolution integral. So take Fourier transform on both sides. This is the Fourier transform equation. The second equation is Fourier transform. This is the Fourier transform equation. This is our signal, convolution sum of two signals x1 and x2. So here let n minus m as lambda. So n will become lambda plus m. So likewise we will interchange the variables and we will write put into format x1 of omega. This is x1 of omega and this is x2 of omega, so that the convolution in time domain will leads to multiplication in frequency domain. This is convolution property, very important property. It will be frequently asked question. So next property, last property, Parseval's theorem. So what it says means the energy inside the signal is nothing but its squares of absolute squares of signal, infinite sum of absolute squares of signal, which is nothing but its from its spectrum also. If we integrate its absolute square sum, we will get energy of the signal. So what is energy formula? Summation n is equal to minus infinity to infinity modulus of x of n whole square. So how we can write modulus of x of n into complex conjugate of n? We can write complex conjugate. So from the inverse Dtft, this is inverse Dtft equation. Here conjugate is there, so we have written conjugate also. So what is meant by conjugate? If signal is there, it will take its conjugate value. If e power j is there, it will take its negative value. That is nothing but conjugate. So e power j omega n, here it will become e power minus j omega n. So 1 by 2 pi integral minus pi 2 pi x conjugate of e power j omega, and what it is nothing but, it is nothing but Dtft formula. So we can write instead of this bracket, closed bracket, we can write x of e power j omega. So x into x complex conjugate, it will become x square. So we have proved the property. This is also very frequently asked question. State and prove Parseval's theorem, or state the Parseval's theorem for 2 marks question. I hope you have understand properties of Dtft. Any 4 properties, learning any 4 properties is important. So while solving problems, we will use all this, we must remember all these properties. Thank you.